What is the application prospect of single-photon imaging?
As you mentioned, yeah, SPAD sensors, even though they have this single photon sensitivity, it may seem like they're good for low light, but they're actually also really good for extremely high light levels because of the way they capture photons. They give you compression of dynamic range for free in some sense. Like the pixel itself, as you said, because there is no well being filled up, there is no, in theory, there is no upper limit to how many photons you can count. In the end, you'll be limited by the speed of your readout, but it's like a slowly approaching limit. Like you, in theory, you never really get there. So you get this extremely high dynamic range, but because SPAD sensors are so new compared to conventional CMOS image sensors, their spatial resolution and their fill factors and their photon detection efficiencies is still much lower than CMOS image sensors. So there have been some recent news articles about some companies releasing megapixel resolution SPAD sensors. So that direction is looking quite promising, but we are still quite far away from having like a 10 or 20 megapixel SPAD camera with like 90% fill factor. But that is something you can get with a CMOS camera. Now, if you want high resolution and if you also want extremely high dynamic range, I think it makes perfect sense to combine the best of both worlds and have high dynamic range scene information come in from pad-based sensor and extract high spatial resolution from a CMOS image sensor. And you can combine these two streams of information and get the best of both worlds. You have high dynamic range and high resolution. And the other reason why I think it's promising is because there are phones out there today that already have image sensor modules with multiple cameras on it, where one of them is a CMOS camera and one of them is a SPAD camera that's currently being used for 3D imaging for a LiDAR-like application. But it goes to show that you can, in fact, have a multi-camera module where you can combine different types of image sensors, in this case, the SPAD and the CMOS camera, in a single module. And then it's then up to the downstream computation to combine that information in a smart way to give you the information that it's capturing.
What are the technical challenges of single-photon imaging?
I don't think SPAD cameras have readout issues per se, but the raw data that the SPAD camera will generate will essentially contain a spike for almost every photon that arrives on every pixel, right? So the volume of the raw data that will come out, this SPAD camera will be way too big to download off of the sensor and deal with in post-processing, right? So for SPAD cameras, I think it is absolutely essential that we come up with smart methods for doing some kind of in-pixel processing, where we extract some information as quickly as possible so that we don't have to transfer all of this photon data off the image sensor, because that's going to require way too much bandwidth and will also consume a lot of power. But that is possible. I mean, you really don't need to send every single photon off to your ISP or AP. You can extract some low-level information on the inside each pixel itself, or maybe by doing some groups of pixel processing, and then send that information off to the ISP or the AP. And there are companies out there today that are already working on some really exciting applications in the real world for just passive imaging using SPAD cameras, even without fusing it with CMOS cameras. And it does make sense to do that in some challenging scenarios. For example, if you have extremely low light, then it absolutely makes sense to have single photon sensitivity there. And if you combine low light with high speed motion, that's really where conventional CMOS cameras do struggle to give good scene information. And that's where SPAD cameras can really have an advantage.